This video is for Chapter 1 of AP Chemistry. I'm not going to spend tons of time on this because most of it should be review, but I did want to go through a few things a little bit more. So you should read through the notes and make sure that you know the information in them. It starts off talking about matter and the scientific method. It distinguishes between theories and models. So you'll want to make sure that you just read through that and some of the key laws that we make sure to pay attention to in science and especially in chemistry. Law of conservation of mass, law of conservation of energy. You do not need to know the people, you just need to know the ideas there. You do need to know the metric system, and you should familiarize yourself with the different metric prefixes. Ones to definitely know are things like milli and centi and micro and deci. Those tend to be ones used in chemistry a lot. As we continue on, you'll see there's some comparisons then between mass and weight. But again, that's something that we spend a lot of time on in things like physics, but we will not spend a lot of time here. It does talk about accuracy and precision in here. This is a topic we talked about last year in first year chem. When we're in the lab, we like to look for more evidence of accuracy and precision and what types of errors we have. And so you can read through that section. Again, that is a review from last year. The next section talks about significant figures. And significant figures is really a way of determining kind of how we round off our answers. And so you can see with an example here, it's maybe a little hard to see the highlighting in this, but you'll hopefully be able to see it better in what I post. But the significant figures are really kind of following certain rules. And we have rules for counting them when we multiply and divide. Really, what I look for and what AP is looking for is that you're generally within one of the correct number of significant figures. It is not a big part of this course. So with limited time, especially this year, we're going to skip it. Dimensional analysis, however, is a big part. And that was a big part last year. It should have been a part of iSTEM for you also. And so, you can see when we talk about dimensional analysis, we're talking about being able to cancel out those units using unit conversions. And so we always want our units to cancel diagonally for us to get rid of them. We are basically thinking about things in the conversion factor being equal across that line of the fraction. So you can see from the table that we've basically taken those equalities and turned them into a fraction so that what's on the top is actually equivalent to what's on the bottom, but now we can start to cancel out our units. This problem-solving method is really important as we continue because even if you don't know exactly how to solve the problem, sometimes you can get to the right answer by using unit cancellation. And I have had students who have been able to solve problems on the AP exam not knowing how to do anything else except unit cancellation to solve that particular problem. Not to say every problem is unit cancellation, but it is a big helper when you're totally stuck. So there is a problem here for you to try. There are a few more problems in the notes, and the answers are given at the end, so you can check those. But you may want to pause right now and try exercise 1.6 and see how you do. So if you paused and you are ready to check, you can look and see how your work compares to mine. Again, notice that the work here is showing everything, including the units along the way. You need to be complete in how you show your work and your explanation. Every little thing will count for AP. Sometimes, putting in the conversion factor is what gets you the points. It's not necessarily your final answer. So we want to make sure that we're showing complete work all the way along. That probably doesn't sound new to those of you who had me last year. A couple other problems that you can try, and again, I'll post answers so you can check. The temperature scale is something that, although temperature is important, and we will talk more about temperature and heat and things like that throughout this semester and especially in this year, the big thing that's important is the Kelvin scale. And so the Kelvin scale is the scale of temperature that's directly proportional to particle movement. The great thing about it is it has no negative numbers, which I think is awesome. We don't use a degree sign for it because of the fact that it's directly proportional to particle movement. The degree symbol is not used as a result. It's not kind of falsely based on other things. And so the two equations that I have boxed there, converting between Kelvin and Celsius, are actually given on the AP equation sheet. They are important, but you do not need to memorize them. You do need to know how to use them, however. So you'll notice I'm skipping a couple problems here in the notes because I don't think that they're super important to convert from Celsius to Fahrenheit or Fahrenheit to Celsius. But I did do partially exercise 112 here, and you can see, if we have a boiling point of 77 Kelvin and we want to convert that to, I just went to Celsius, we're usually not going to go beyond to Fahrenheit, but that would be negative 196 degrees Celsius. Again, scientists really don't use the Fahrenheit scale, although, Americans use the Fahrenheit scale. Many parts of the rest of the world, they use the Celsius scale. And scientists definitely use Celsius and Kelvin primarily. The next section talks a little bit about density and how to calculate that, and we'll maybe look at that again later. But it's definitely a great way to identify a type of matter that you may have. It's a characteristic that is unique oftentimes to what you have. The last section is what really kind of one of the most important parts here. And this is basic stuff that we did cover in first year chem, but it's maybe been a while. So just to review, we do have states of matter that we can think about. Our solids are rigid. They have a definite shape and volume, meaning if it's definite shape, it holds its shape on its own. Definite volume means I can't really squish those particles together anymore. Liquids have a definite volume. I really can't squish liquids very easily. Like if you've ever accidentally done a belly flop, it's a poor dive, and that turns into a belly flop. You've tried to compress water with your body, and it doesn't work so well, and it hurts. But liquids don't have a definite shape, so they'll take on whatever shape of their container. Gases, on the other hand, can be compressed. They're usually highly compressible, and they are something that can take on the shape of their container. Two other words that go with that, vapor and fluid. Vapor is the gas phase of a substance that is normally a solid or gas at room temperature. Fluid is anything that can flow. So think about the FLs going together there. So we're talking about gases and liquids being fluids. So just because you call something a fluid doesn't mean it has to be a liquid. It can also be a gas. We also talked about mixtures last year. We talked about homogeneous and heterogeneous, and mixtures are things that can be physically separated. So remember, homogeneous mixtures have indistinguishable parts. So air, for example, I can't tell the difference usually as long as it's pretty clean air. From the nitrogen to the oxygen that's in the air. So that's a homogeneous mixture. Heterogeneous mixtures have very distinguishable parts. And all of these types of mixtures can be separated by physical means. Physical means like filtering, what we call fractional crystallization, which we won't really focus on in this class, but that would be like making rock candy, for example. That's kind of fractional crystallization, distillation, and chromatography. And so you can see some pictures here. I know that my filtration picture isn't really that great, but I hope you get the idea. But filtration, distillation setup here. Basically, we're separating things based on boiling points, and chromatography. And so filtration is definitely the one you're most familiar with, but chromatography is one that we've also done. And keep in mind that what we're thinking about there and what I have starred there is really important. We're separating that mixture of inks based on differences in attraction of the ink to the paper, which is called the stationary phase, and attraction to the liquid phase, which is like the water potentially that is moving and wicking up the paper. And so things that travel faster up the paper are going to be more like chemically like the solvent than they are like the paper. And so if you look at our picture here, kind of our blue purple inks that are at the top there are much more like the solvent because they've moved up faster, and our yellow inks are much more like and much more chemically attracted to the paper, which is why they stay towards the bottom. The last part then, pure substances. Remember, pure substances are things like elements and compounds. So they, they're really those fundamental kind of building blocks. Compounds can be separated into elements by chemical means only. And by chemical means, I mean things like a chemical change occurring. Elements cannot be broken down and maintain kind of the properties of that element. They can be broken down into things like, protons, neutrons, and electrons, but those don't fundamentally have like the properties of sodium anymore. So a proton is a proton is a proton. It doesn't matter where it came from. But once you put those protons together, 11 of them together in a certain way, then you have a sodium atom. Versus if you only have 10 of them, now you have a neon atom. So that's kind of the difference there. You can see a chart here also that really kind of breaks down how we think about things and where things are at. And again, that's a review, and you can look at chapter 1 of your textbook to review that a little bit more. Thank you.